Polynomials. I feel like it started on a hard one. I'm not for sure why here, but we'll just go with what they have because these are the topics. So polynomials, I guess I'll probably talk about what a polynomial is on the next topic. I don't really know why it started right here. Okay, so a polynomial is any expression that has a positive exponent, I believe is the definition. So this one, there's a lot of multiplying and dividing and subtracting and different things with polynomials. Anytime you learn a new type of math expression, you go through the normal operations. Like, it's kind of crazy when you get into like really hard math. They still just do adding, subtracting, multiplying, dividing. It's just like different. So that's basically what this whole section is about. It turns into a combining like terms, though. So like you have to combine like terms. So to combine like terms, they do have to have all the same, like the x's and y's, like everything besides the coefficient have to be the same. So on this one, again, I feel like it started out on a hard one here for some reason, but that negative, when you have a negative out in front, it's like having a -1 out in front. I'm going to distribute this -1 to everything inside of here. Okay. So this becomes positive 2x squared, negative 3xy, positive 4y squared. And then from here on out, it is a combining like term. So like I said, everything besides the coefficient has to be the same. So like x squared and x squared, I have 2 of those and 5 of those, so I have 7 of those. This xy and xy, I have -3 of those and -2 of those, so I have -5 of those. This y squared, I have 4 of them plus 1 more on the right, so I have 5 of those. Okay. So everything besides the coefficient has to be the same to be able to add those up and subtract those. And we're going to do a bunch of that. So, all right. Now kind of jumping back to something a little easier here. The degree of a polynomial. Just some terminology of a polynomial real quick. The degree is the highest exponent. Okay, the degree is the highest exponent. The degree does tell us a couple things. The degree here on this one would be 3 because of this right here. The degree tells us how many possible solutions you have to a problem if you're solving it. So like this one has up to 3 different solutions, which we don't get into solving these too much in this class, but we might see some of those on Wednesday. The other one that I want to talk about that they don't, it is mentioned on this topic, is the leading coefficient. For this, I'm going to put front number because I like to do non-math definitions. But first you have to have exponents lined up from greatest to least. Okay. So it's actually the front number of the highest exponent. And I'll rewrite the next problem to kind of show you what I mean by that. So the degree on this one is 3, and my leading coefficient is 3 as well on this one. Whoa. Okay, so if they were to give you a problem like this, like, I'm going to rearrange this problem real quick so you can kind of see it. But if I had like 3x cubed, why is my pencil not working? Oh my goodness, let me exit out of this real quick and see if, because my pencil is like not catching there. Okay, so if I like had this problem right here written like this, what you have to do is identify the term with the highest exponent, okay? Technically, you could rewrite it like this and rewrite it in decreasing order, okay? But really, this is the only thing I need to know is this is my term with the highest exponent. So my degree on this one is 5. and the leading coefficient of this problem is going to be -7, okay? Because if I wrote it correctly, the highest exponent would be in the front. So that's what, it's a front number is the leading coefficient, but it's always the one that's with the highest exponent, if that makes sense. So the degree tells us like how many possible answers there are. The leading coefficient kind of tells us the direction of the graph, like whether it increases or decreases. I don't think we'll go into that too much in this class, but those two numbers do tell us some important information. All right, sum or difference. So if I take one polynomial plus another polynomial, adding is the easiest of these. It is just combining like terms. So 3x squared plus 2x squared is 5x squared. -5x plus 4x. -5 plus 4 would be -1. And then 2 minus 3 would be -1. So it is just combining like terms when you are adding and subtracting these. Now subtracting is harder because you got to deal with a negative. And I'm going to show you a way that I do that to really help you with signs, because if you start working with this, what you're going to have to do is minus a negative and things like that, and it does get very tricky. So what I would do, just like on that very first problem where I put a -1 out in front, I would go through and distribute that negative through all this. So I would make this -4x cubed minus x plus 5. Just rewrite it like that. And now it is just a combining like terms problem. And I don't have to think about minus and negative and different things like that. So 6x cubed minus 4x cubed would be 2x cubed. -2x minus x would be -3x. And 1 plus 5 would be 6. Okay. So when it's subtraction, I would rewrite the second one, the one with the minus. I just change all the signs in there because that makes it so you don't have to do minus negative. If I didn't do that, I'd have to do 1 minus a -5. 1 minus a negative becomes plus, so that's 6, but I don't want to have to think about signs and things like that. So if you just rewrite this by distributing the negative through it, it makes it so much easier. There's also something else that happens on one of these. I'm going to edit that problem real quick. That makes it so much easier. All right, 2x squared y minus 3xy squared plus 4 plus x squared y plus 2xy squared minus 1. Sometimes you'll even see when you write these out, you can write them like underneath each other to add them up, but just combine like terms. So x squared y, so they have to be exactly the same. Those both have x squared y in it, so you got 2 on the left, 1 on the right, so you have 3 of them. xy squared, so -3 plus 2 would be -1 of them. And then the numbers are always easy. 4 plus -1 would be 3. Okay. So they have...
It's like distribution with exponents then.
Well, we'll get into the distribution. This is more like combining like terms. Like where you just combine the ones that they have to be exactly the same. Everything besides the number out in front has to be exactly the same for them to be able to do it. All right, this one, I edited it, so let's see if it works the way I wanted it to. Yeah, well. All right, so on this one, it's negative, so what I'm going to do first is I'm just going to rewrite this one and distribute the negative through. So distribute the negative through. It's like taking everything times -1 in there. So -3a squared b minus ab squared plus 2a. Like just take 2 seconds and rewrite that, and it makes it so much easier. So now I have 5a squared b minus 3a squared b. A squared b on both of those. So 5 minus 3 is 2. Now, if I look over here, I have negative AB squared here, but I don't have one over here, right? There's not one over here. So I'm just going to rewrite that. This is another reason that it makes it so much easier to distribute that -1. Because, look, originally I had AB squared right here, right? Is positive. But I subtracted it, which makes it negative. So what you are actually doing, if this makes sense, I have 0 AB squareds on the left, and then I'm subtracting a positive AB squared, which makes it negative. If that makes any sense. There's not one on the left, and then it's positive. So if you just distribute that negative through, it takes care of that situation and you don't run into that. It's very common to just be like, oh, I don't have one of these over here, so I'm just going to rewrite it. But you have to change the sign because of the negative. So distribute that -1 through. It makes your life so much easier. And then 3a plus 2a would be 5a. All right, so that's adding and subtracting. It's kind of combining like terms. When you get into multiplying, this is distributing. Okay, so we have to take that 3x times everything inside there. 3x times 2x squared would be 6x cubed. You add the exponents. There's 1x out here, 2 right here, so there's 3 now. 3x times 4x would be 12x squared. And then 3x times -5 would be -15x. So this one is just distributing, and that's the way we do the multiplying for most of these. Try to go back up there so you can see it while I write this one. -2x times 3x squared. Same thing on this one. We are going to distribute the -2x times everything inside of there. Just got it. This has a negative. This topic does a negative coefficient, the negative right here. But it's going to work the same way. -2x times 3x squared would be -6x cubed. -2x times -5x would be +10x squared. And -2x times 4x would be -8x. All right, this one, 2xy. So this one is adding some y's in here. But nothing's really going to change. You just have to add. And if there's one, we're multiplying by 1x on the outside. So we're going to add 1x to each of these. 2xy times 3x squared y would be 2x cubed y squared. Right, I'm adding 1x and 1y. 2xy times -4x squared would be -8x squared y cubed. And 2xy times 5 would be 10xy.
How come you didn't have to do 2 times 3?
What'd you say?
Why did you have to do 2 times 3?
I should have. My bad. Yeah, 2 times 3. I forgot to write 6 there. So 2 times 3 is 6. It's Monday morning for me, too. 2 times 3 is 6. I was thinking so much about the x's and y's, I forgot to do the numbers. So, yes, 2 times 3 is 6. All right, so that's distributing. The next thing is foiling, which you might have heard of before. But this is when I have a binomial times a binomial. What foiling is just an acronym to make sure that I multiply everything in the left one times everything on the right one. So I'm going to take this x times both of these, and then I'm going to take this 3 times both of these. So you got to take everything in the left times everything in the right, okay? So what the FOIL is, I'll write it out as I go. FOIL is you take the first term times each other, the first in both of them. X times x is x squared. Then you take the outside terms in both of them. X times negative 5 is negative 5x. So now I've taken this x times both of these over here, right? So now we got to move to the 3. So now I do the inside terms times each other. 3 times x would be 3x. I'm going to write that underneath my 5x because I can combine those, right? Negative 5x and 3x I can combine. And then my last one here is you multiply the last terms. 3 times negative 5 would be negative 15. Okay, so first, outer, inner, last. And again, all that's really doing is making sure that you take this x times both of these, and then you take this 3 times both of these. So now you can combine like terms, and I get x squared minus 2x minus 15. The next topic's just foiling, but a little bit harder. So first, 2x times 3x would be 6x squared. Outside would be 2x times negative 4. That would be negative 9x. Inside would be 3 times 3x would be 9x. So I'm going to write that in my x column. And then the last would be 3 and negative 4 would be negative 12. And then combine like terms, negative 8 plus 9 would be positive 1. Foiling is something you do a lot of, and like on Wednesday, we actually do the opposite of foiling. So I'm sure as I look down these, there's a lot of foiling topics right here. So like you said, there's a lot of topics due this week, but hopefully some of them go faster. And once you get the hang of foiling, it's not too bad. So this one is a foiling topic with an x and a y, but everything's the same. X times x. That's my f, so x squared. That's the first. And then outer, x times negative 3y would be negative 3xy. My inner, 2y times x would be positive 2xy. And my last here, 2y times negative 3y would be negative 6y squared. So now I combine like terms. X squared, negative 3 plus 2 would be negative 1. You can always combine the outside and the inside on these. I shouldn't say always, but almost always. All right. This is... Honestly, on this one, these are called conjugates. They call these conjugates. Conjugate. It means they have, they're the same thing with a different middle sign, if that makes sense. So like one's x plus 4, one's x minus 4, okay? So they're the same thing, they just have different signs. There is a shortcut to this. I do not like teaching the shortcut because I never want you to mix it up. I'll kind of show you what happens when we FOIL this out. So x times x is x squared. X times negative 4 would be negative 4x. So we got at first, outside, x times 4 would be positive 4x. That's my inside. And then my last 4 times negative 4 would be negative 16. So now I combine like terms. Well, negative 4x plus 4x cancel out, so I just get x squared minus 16. When you multiply conjugates, the middle terms always cancel out. So technically the shortcut is to just do the first and the last. You don't have to do the outside and the inside because they're going to cancel out. But like I said, I do not even show you that way because I'd rather you just take the time to FOIL it all out and cancel it all out. Cancel the middle terms out because I never want you to accidentally just do first and last when you should have done the whole FOIL. So it doesn't take that much longer just to do those. But yeah, when you multiply conjugates, the middle term should always cancel out. But again, just FOIL it. You'll get good at foiling, and it won't take you very much longer, okay? So when they show you this topic on Alex, like, just FOIL it. So this, again, is a conjugate. Even though I have an x and a y, it is the same exact thing with a different middle sign, 2x plus y and 2x minus y. You could do the shortcut if it really makes sense, but please, 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 please do not do the shortcut when you're not supposed to. So do FOIL. 2x times 2x is 4x squared. 2x times negative y would be negative 2xy. Y times 2x would be positive 2xy. And then y times negative y would be negative y squared. So when I add these up, 4x squared, the negative 2xy plus 2xy cancel out. So I get negative y squared.
I like how you did for the other part, for the inner and last, you did it underneath, so you don't have all these.
Yeah, like I put these like that. Yeah. Anytime you're writing them out and you can put it in the same column, it makes it so much easier to add and subtract it and combine like terms. I forgot how much foiling is in this section. I'm going to do this one, actually. So this one says squaring a binomial. When you square something, so remember if you have 6 squared, you're doing 6 times itself that many times. 6 times. This is 6 times 6, right? You just kind of write out what's being squared. Same exact idea here. I'm actually just doing, I want to use black. I'm actually just doing 2x minus 5 times 2x minus 5. And again, there is a shortcut here, but I don't teach it because it's just FOIL. Y'all can FOIL fast. 2x times 2x is 4x squared. 2x times negative 5 would be negative 10x. Negative 5 times 2x would be negative 10x. And negative 5 times negative 5 would be positive 25. So 4x squared, negative 10 minus 10 would be negative 20 plus 25. I will show you the shortcut real quick just for those who get it, but if it does not make sense, just FOIL. On all these problems, just FOIL. The shortcut is, since you're multiplying the same thing here, your answer always ends up being let me just rewrite it real quick. 2x minus 5 squared. Don't do this. I'm putting this to the side here, but I should say warning, just FOIL. 2x, so like the shortcut is you just do 2x squared. 2x times 2x would be 4x squared. And then you do negative 5 squared would be positive 25. The middle one is what's hard here because what you do is you multiply those. You do 2x times negative 5, and then you double it. So it's actually 20x, and since the sign's a negative, that's a negative. That's a hard shortcut, okay? What'd you say?
I said it almost seems harder.
I know. That's why I don't even like it. I'm just going to write it. Just FOIL. It's so much easier just to FOIL, just FOIL. But that is one thing that they may like show you there. But I highly recommend y'all get good at foiling, just FOIL it. So on this one, I'm doing 3a minus b times 3a minus b. FOIL it. 3a times 3a would be 9a squared. 3a times negative b would be negative 3ab. Negative b times 3a would be negative 3ab. And negative b times negative b would be positive b squared. So I have 9a squared minus 6ab plus b squared.
With the final, how many subjects are we going to revisit from the midterm?
The final is just the second half of the class questions.
Okay, so the other ones are going to pop back up?
No, they will not. All right. So this is just foiling with negative numbers, but nothing's different. Negative 3x times negative 2x would be positive 6x squared. Negative 3x times negative 5 would be positive 15x. 2 times negative 2x would be negative 4x. 2 times negative 5 would be negative 10. Combine my like terms and I get 6x squared plus 11x minus 10. So I don't even know. I feel like we just did like 7 FOIL topics. When I said y'all will be good at foiling, that's why, because you're going to do it about 20 times. So foiling, I'm going to say this because this ties into the next one. Foiling is just an acronym to make sure that you're multiplying everything in the left one times everything in the right one. That's like the rule is you always multiply everything in the left one times everything in the right one. So when I get to a problem like this, it is very much like foiling, but I have 3 terms on the right side, so I can't use the acronym foiling, but I'm using the idea of foiling. I'm going to multiply everything in the left times everything in the right. So I'm going to take this x times everything over here. So x times x squared would be x cubed. X times negative 3x would be negative 3x squared. And x times 1 would be 1x. Okay. So now I've done the x times everything on the right. So now I want to do the 2 times everything on the right. So positive 2 times x squared would be positive 2x squared. 2 times negative 3x would be negative 6x. And 2 times 1 would be 2. And again, you can see that as I was doing it, I wrote what matches up. Like the x squared column is here, the x column is here. And that does help you when you go to combine like terms. So I have x cubed minus x squared minus 5x plus 2. So just like foiling, just a little bit longer, you do everything in the left times everything on the right. Oh, we only got like 2 topics left. We may jump into the next topic just a little bit. So we have done adding, subtracting, multiplying. So now we get to do dividing. Okay, so the fraction bar does mean to divide. This is the easiest way to write this. What I am doing on this one is I am dividing all 3 of these terms, this term, and this term. I'm dividing all 3 of them by 3x. I think probably when you start this, the easier way to write this is just to go ahead and separate it out. and write it as 3 different division problems. So I am dividing everything in the top by 3x. So now I can just work each of these individually. 6 divided by 3 is 2. I got 3 x's on top and 1 on the bottom, so that leaves me with 2 on top. 9 divided by 3 is 3. 2 x's on top, 1 on the bottom. That leaves me with 1 x on top. Here you have the same thing divided by the same thing. That becomes 1. If you need to walk through it, 3 divided by 3 is 1. X is on top, on the bottom, they cancel out. So on the division problems, you just got to make sure you divide everything on the top by 3x, whatever's on the bottom. I don't know if you're going to run into this problem, but I kind of want to work it just in case. So let me, oops. Let's work this one, just in case you run into this one. Same thing on this one. I'm going to divide everything on the top by 5x cubed. Oh, that's 5x cubed. Okay. So just write it out as like 3 separate terms, 3 separate problems right here, and then go through each one. 10 divided by 5 is 2. 4x is on top, 1 on the bottom. I'm sorry. 4x is on top, 3 on the bottom. That leaves me with 1 on top. 5 divided by 5 is 1. 3x is on top, 3 on the bottom. They cancel out. 15 divided by 5 is 3. I got 2 x's on top and 3 on the bottom, so that leaves me with 1 extra x on the bottom. Okay. I don't know for 100% sure if you're going to run into that on this topic, but that is a possibility that I can't take away all the x's on the one on the right, so that's why I work them as separate problems. I got 2 x's on top and 3 on the bottom, so I got an extra x on the bottom. We kind of did that. We did that exponent stuff last week, right? Yeah. And the last one here, same idea, you just got multiple variables. So the problem may look something like this, but you are dividing everything by 5ab. Okay, so you got to go through each one. Do the numbers, do the A's, do the B's. So 15 divided by 5 is 3. 3 A's on top, 1 on the bottom. So that leaves me 2 on top. B squared divided, or 2 B's on top, 1 on the bottom. That's 1 extra on top. On the next one, 10 divided by 5 is 2. 2 A's on top, 1 on the bottom. So that's 1 on top. The B's, 1 on top, 1 on bottom, they cancel out. 5 divided by 5 is 1. A on top, A on bottom, they cancel out. 2 B's on top, 1 B on the bottom, they cancel, or sorry, that'd be leave me with 1 B, so I don't need to write that 1. So we just say the 5's cancel out. You're left with 5's cancel out, A's cancel out, 2 B's on top, 1 on the bottom, there's 1 extra B on top. All right, that's polynomial.